This question is pretty standard word problem material. If C is the number of units of corn and R is the number of units of rice, then Pat earns a total of 17C plus 13R dollars, and the number of units combined is C plus R. We're looking for C. Let's move on to the data statements separately first. Statement 1 gives us the total number of dollars, so we can write the following equation. Generally, we would not have enough information to solve completely in this case, since we don't have, say, the total number of units, giving us two equations and two variables. But this question is a good example of why it's important to at least check an answer by analysis of cases if you have the time. Because considering actual possible values of C and R encourages us to note that C and R must be integers. That's what this unopened package business is all about, as referenced in the question. A single equation is insufficient to solve for two variables when those variables can be any real number, but it may be sufficient if we know that both variables must take on integer values. So we want to check cases for this equation in which C and R are integers. We can note two fairly different ways of getting to the answer from this point. First, you might notice that the prices are distinct prime numbers. It's always worth keeping an eye out for prime numbers because where they are present, there are fewer possible cases, and it may be possible to solve exhaustively by cases. To do that, we obtain the prime factorization of 282, and we can write it on the right side of this equation. We can find this prime factorization by dividing 282 by 2, and then seeing that 141 is divisible by 3 because its digits sum to 6, which is divisible by 3. We can then confirm that 47 is a prime number by noting that it's smaller than 49 and checking the possible factors of the square root of 49, or 7, and below down to 2. That means that in this equation, all of the numbers are prime. 17 and 13 must be multiplied and added to yield a multiple of 47. Two 13s and a 17 doesn't yield 47, but two 17s and a 13 does. That means that in this instance, there must be twice as many 17s as 13s. We can then write the equation in this fashion, and that allows us to find that R is 6 and C is 12. If you hadn't noticed or didn't take the prime factor approach, another way to do it would be to find the only possible integer solution for R and C. After trying a few values, you might have noticed or gotten an idea from statement 2 to get an idea from a case. Granted, we are evaluating statement 1 alone currently, so looking at statement 2, we have to be careful not to violate the separately first maxim. But we can look at statement 2 just for an idea of how to build a case, not in order to take statement 2 as a piece of data. That gives us the idea that C might equal 2R, and that leads straight back to the case that we discussed. If you convince yourself that's the only possible case, then we reach the same result. The conclusion is that we have a definitive possibility, a definitive answer to the question, and statement 1 is sufficient. Statement 2 tells us that C equals 2R, but without the benefit of statement 1, we don't know the total value of these packages. For example, the number of packages could be 6 and 12 or 5 and 10, yielding different answers to the question. We don't have sufficient information to answer definitively here, so statement 2 is insufficient. The correct answer is A.